All right, I'm going to go over your fall final review. The first thing we want to do is give different names for L, M, and N. So L is right here. It includes points F, B, and G. So for line L, it can also be named FB or BF. Oh, lines, sorry. They got to have arrows. BG or GB. Or FG and GF. So all of those are possible names of line L. And the arrows aren't on your key. That is incorrect. They're supposed to be arrows. Line M is right here. So M would be AB or BA. BC or CB, and then AC or CA. All right, and then lastly, we have N, which is here, and it includes E, B, and D. So that would be EB or BE, BD, or DB, and then ED or DE. All right, then we have to name 3 collinear points. Well, on line L, that would be F. Well, I guess I should say points. Hold on. Points F, B, and G. So that is one possible answer. By the way, you don't need all of these answers. You just have to write one name for each of the lines for number 1. You don't need to write all of them. For the collinear points, you just need to choose one of these options. Line M is here, so that would be points A, B, and C. And then the last one is line N, which would be points D, B, and E. And they could be in alphabetical order. The points can be in whatever order when you list them like this. It doesn't matter. Typically, I will list them in alphabetical order, even though I did not do that this time. All right, so now we're going to use this image to answer the next 2 questions. It says, find the length of HI. If HJ is 21.3, which is this entire thing, and then JI is 6.8. So that means that we would subtract them. So 21.3 minus 6.8 would give you 14.5 feet. For the next problem, it tells you, oh, I didn't get rid of all of it. There we go. It tells you HJ is 2x, so the whole thing is 2x. IJ is 3, and wait a minute. Oh, sorry. 2x is HI. And then HJ is 3x minus 1. Like that. Okay. So that means that 3x minus 1 has to equal to both of these added together, because that makes the whole thing. So 2x plus 3. Subtract 2x on both sides. Add 1 to both sides, and x is 4. But it wants to know what HJ is, so the whole thing, we plug it back in. 3 times 4 minus 1 is 12 minus 1, so that means it's 11. All right, for number 5, it says, now 5 and 6 are not related, so don't think that. But it says ON is this line right here, that it bisects LOK. So that means that both of these are the same angle measure. LON is 3x plus 10 degrees. And NOK is 6x minus 2 degrees. Because it is bisected, they're equal. So we do 6x minus 2 equals 3x plus 10. Subtract 3x from both sides. add 2 to both sides, and that means that x is 1. But it wants to know LOK, which is the entire angle. So you can plug it into both things and then add those together if you want to, or you can plug it into one and then double your answer, which is usually what I do because it's just easier math for me. So 3 times 1 plus 10. 3 times 1 plus 10 is 13. And this is the measure of angle LOK. And 3 times 13 would be 26 degrees. That's different on the key. Why is that wrong? Move 3, add the 2. That would be 3x is 3. Huh. Oh. It's 3x plus 10. That's what happened. Okay, now I understand. This is 12, and this is 4. Sorry. So this is 4. 3 times 4 is 12, plus 10 is 22. And that should be a 2, not a 3. And then 2 times 22 is 44. So sorry about that, but that's how that happened. It's also why I check my answers before I move on. As you should as well, because it's easy to mess them up. Even we do it. Everybody's human. Okay, it says LON is 4x plus 62 degrees, and NOK is 3x plus 69 degrees. Find the value of x so that they are perpendicular. So that means that each of these OK would be perpendicular to MN. Yeah, so each of these would be 90-degree angles. So you could pick, it doesn't matter which one you would do. You would either do 4x plus 62 equals 90, or 3x plus 69 equals 90. And it doesn't matter which one you do, you should get the same answer no matter what. On this one, you would subtract 62 on both sides. 28. Okay, and then this one you would subtract 69 on both sides, which would get you 21, both of which still give you 7. And again, you only have to do one of these. You do not have to do both. I just need you to understand that it could be done either way. All right, then we start with our graph stuff. So it says, what is the midpoint of PQ? Well, P is at negative 5, 5. And Q is at 6, negative 3. All right, so the midpoint is you add your x's together and divide by 2. And then you add your y's together and divide by 2. So that gives you 1/2, and 5 minus 3 is 2 over 2, so 1/2 and 1. And whenever you graph that, which is right here, it should be in the middle. You could also say that this is 1, 2, 3, 4, 5, 6, 7, 8. Split that in half and go 1, 2, 3, 4, and then follow it over to its intersection. So that's a way that you could do it if you're given a graph, but if not, you would need to actually do the math for it. Distance, remember that distance formula is you subtract your x's and square them, subtract your y's and square them, add that together and take the square root. So that would mean that we have negative 5 minus 6 squared plus 5 plus 3. It's minus negative 3, which is plus 3. Negative 5 minus 6 is negative 11 squared. 5 plus 3 is 8 squared. 11 squared is 121. 8 squared is 64. Just want to make sure I was still right. All right, 121 plus 64 is 185, which I wonder if that can reduce. 5 would go in there. 3, 5, 6. 5 will go into 35. 7 times, so 5 times, no, those are prime. So that it's only square root of 185. So you could do it that way. You could also, if you're given a graph, do your right triangle like this and like this. This green one is 1, 2, 3, 4, 5, 6, 7, 8. The red one is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, which if you notice are here and here. So you do Pythagorean theorem. So you'd say x squared plus 11 squared is equal to c squared. 8 squared is 64. See? 11 squared is 121. See? And then you take the square root of both sides, which is what happened here, right? So it's the same process. So it doesn't matter which one you choose to do, which means C is the square root of 185. So it doesn't matter which way you choose to do it. Pick one of them, but they would both work. All right, constructions are going to be hard for me to do digitally. I will put these constructions as a separate video as well for you to watch. I can describe it though. So the perpendicular bisector, you're going to put your needle here and extend your pencil between halfway and the other side. So anywhere between here, you're going to put your pencil somewhere between those 2 points. Okay. And then when you do that, you're going to make a big arc all the way around. This is the Jesus fish. And then without changing the size of your compass, you're going to put your needle here now. And remember, you're not changing your pencil. And then you would bring it around this way, and then it would be in the middle. Of course, mine's a really terrible construction because I just sketched it. But that's how you would do that. And whenever that happens, when you do bisect it, this is 90 degrees and these are congruent. So don't forget those properties. That's important. And then whenever you copy an angle, you just draw a randomly sized segment. It doesn't matter with the straight edge. Then you put your needle here and extend your pencil so that it just is inside the angle. It doesn't matter. And then you make an arc. And then without changing the size of your compass, you put your needle here and then make a little bit of a bigger arc. Then you measure the arc you made on the original angle. So you would put your pencil here and your needle here to measure. You're just measuring. And then you would put your needle here and then mark with your pencil. And then after that, you would use your straight edge to connect this end through that. And then it would be your copied angle. And don't forget that means that these are congruent angles. Then to bisect an angle, the first thing, it starts off the same. You would put your needle here and you would draw a randomly sized arc. It doesn't matter. It just needs to be inside of the angle. And then you can change the size if you want to, but I typically keep it the same the whole time. So then you would put the needle here and just a random size. You just need to make sure that it goes at least through the middle. And then you would make an arc, something like that. And then you would put the needle here without changing the size and make another arc like that. And then you would connect the center through that, and that would be an angle bisector. And both of these would be congruent. How does this would be DEF, this is F, compared to DEG. So remember that the measure of angle DEF would equal to half the measure of angle DEG, because you just split it in half. Or you would double the measure of angle DEF to equal the measure of angle DEG. All right, then we start logic. So this one is pattern recognition. To get from a half, -2 to 1, you multiply times -1/2. To get from 1 to -1/2, you multiply times -1/2. To get from -1/2 to 4, you multiply times -1/2. You get the point. Okay. So for the next one, you're going to multiply -1/8. Sorry. This times -1/2, which negative and negative give you a positive. 1 times 1 is 1. 8 times 2 is 16. The law of detachment means that's the AB. So if Joe saves $2,000, then he will buy a car. Joe saved $2,500, which is it's more than 2,000, but it means that he at least saved 2,000. So then we can say he will buy a car. All right, using the law of syllogism. So remember that's PQ to QR. It's like the transitive property whenever we do proofs, but it's the law of syllogism whenever we talk about laws. So it's where we take this middle part out. If Johnny runs, then he will lose weight. If he loses weight, then he will be healthier. So if Johnny runs, then he will be healthier is our conclusion. All right, so all of these do have symbolic statements. Conditional is just P then Q. Excuse me, sorry. Inverse is not P, then not Q. That's where you either use the word not or somehow negate P and Q. Converse is flip-flop. So Q then P. Remember, Converse are shoes that you put on your feet, and so we're flip-flops. So it flip-flops. Contrapositive is the longest one, so it's both. It's not Q, then not P. All right, so this is my P. This is my Q. Converse would be to flip-flop those things. So if I pass geometry, then I study for the exam. Inverse would just be the original statement, but put not. So if I don't study for the exam, then I won't pass geometry. Contrapositive is both, so we're basically going to take this and put nots in it. So if I don't pass geometry, then I won't study for the exam. All right, then we have some truth tables. So remember, for both, it's always true, true, false, false for P's. That part doesn't change. And then for Q's, it's opposite. So true, false, true, false. And then it depends on the table how it goes. So not P. Remember, don't do this because you can't erase it as easy as me. But we can ignore this because we just need to focus on the P right now. Not P, you just change it. So the true becomes false and the false becomes true. And then we do that same thing for Q, which means I can ignore this currently and this because I really just need to look at the Q. So that true becomes false and false becomes true. And then what I'm doing is comparing those nots with an or. Remember, the V is an or, which means it's always true unless they are both false. So this is the only situation where it would produce a false. Every other time where there is a true, it will be true. All right, on the next one, we have not P, so I'm going to ignore the Q for right now because we don't need it. Not P means all these trues become falses and falses become trues. Then we need to compare not P or Q. The V is an or. So I don't need this right now because we're not comparing that. And we're comparing it with an or. So anytime there is a true, it will make it true. The only time it's false is if they are both false. Okay. Now we need that last column we just did and the P. So we don't need this, we don't need this. We're going to compare these two columns with an and. So remember, whenever it looks like an A but without the little line, it's and. Ands are always false unless they are both true. So anytime there's a false, it's going to be false. This has a false, this has a false, and this has a false. This top one that is both true is the only time an and will be true. All right, those are our final answers. All right, in this next one, it tells you P is false and Q is true. So what we do is we're going to make a truth table. But we're only going to do it with one row because we already know what P and Q are. Now we do need a not P. And then we're going to compare that not P and Q. So like that. Your P is false, your Q is true. But we need not P. So I'm going to ignore this for a minute. Don't do this. Remember, not P means that that false needs to become true. And then I'm going to compare the not P with Q. So I don't need this guy anymore. And we're comparing them with an and, which means anytime it's a false, it's going to be false. But this is both true, so it is true. Our final answer, that's supposed to be an R, is true. All right, now we got proofs. Everybody's favorite topic. I hated proofs too, just so that you know, whenever I was in high school. I totally get it. All right, the reflexive property is like a reflection. So whatever is there just repeats again. The symmetric property is whenever you flip it over the equal sign. So these two would flip-flop around, which means now that 10 is there, y would be there. Transitive property is where you ignore the middle part, okay? So, and it wants you to come up with this. It gives you the answer. This is the answer, right? Where you're supposed to ignore the middle part. So the thing that's missing is J. So that's what has to repeat. And then what it ends with is L. So this is normally what we ask you for, the answer. And what you would do is you would ignore that and put these two together to get that answer. So in order to come up with the second half, you look at the thing that is missing here from here, which is the J. The J is missing, and that has to, because that has to repeat. It has to be this middle part that touches each other. And then whatever it ends with, this one should end with as well. So that's kind of how you approach that. Addition property just means you're going to add something to both sides. So since the RS has a 20, my TU needs to also have a plus 20. Same thing with the subtraction property. You're going to subtract something from both sides. So this X has an 8 with it. This one doesn't, which means they basically subtracted 8 on both sides, which means the Y now has a minus 8 with it. Substitution, that means that if A is 20, we're going to plug 20 in for that A. So it's 5 times 20. I have to write the reasoning for each of these. So QA is equal to QA. That is like a reflection. So it is the reflexive property. These repeat. So we take them out and then first and last go together. That is the transitive property. Anytime we see this between, and we are talking about segments, these are not angles, they're segments, then it is segment addition. Segment addition postulate. This right here tells you what this one is. It's the definition of midpoint. It goes from congruent to equal, which is the definition of congruence. And then this one says a linear pair is supplementary. That is the definition of a linear pair. All right, then we have a few proofs. This will be as easy as the proof is on your test, where you're just going to end up setting things equal to each other or equal to something else and then solving that equation. So on the first one, it tells you that 5 and 6 are vertical angles. It tells you the measure of angle 5 is equal to x. The measure of angle 6 is equal to 6x minus 290. And all that is given to you. So the next thing we can do is say that those angles are equal to each other because they are vertical. And then we just substitute. So instead of the measure of angle 5, we're going to put x. Instead of the measure of angle 6, we're going to put 6x minus 290. You know what? I don't want to have to do this in more steps. So I'm going to flip-flop these around. Measure of angle 6 is equal to measure of angle 5 because that doesn't matter. And then I'm going to do it this way. You could have done it the other way. You just would have had to do the symmetric property to flip it back around again. So that's substitution in steps 1 and 2. You can either move the 290 or the x first. It doesn't matter which one you do. I typically will always move variables first. So if I subtract x on both sides, I have 5x minus 290 equals 0. And because I subtracted on both sides, it is the subtraction property of equality. And then I'm going to add 290 on both sides. And because I added on both sides, it's the addition property of equality. And then I'm going to divide by 5 on both sides. And that gives me 58. And because I divided, it's the division property of equality. And we're done. All right, we list all of our givens. Angle 1 and angle 2 are a linear pair. The measure of angle 1 is 2x minus 4. The measure of angle 2 is 2x plus 4. All of that is given. Now, it tells us they are a linear pair. Remember, you cannot say a linear pair is 180. You have to say it's supplementary first. So 1 and 2 are supplementary. And that's the definition of a linear pair. Then we can add them together. So the measure of angle 1 plus the measure of angle 2 is equal to 180. And that's the definition of supplementary angles. Now we're going to substitute. So the measure of angle 1 is 2x minus 4. The measure of angle 2 is 2x plus 4. So that was substitution from step 1 and 3. Then we need to combine like terms on the same side. 2x plus 2x is 4x. Negative 4 plus 4 is 0. So that goes away. And anytime you combine like terms, that is called simplify. Then lastly, we divide by 4 on both sides, and that gets us 45. And because we divided on both sides, the division property of equality. All right, now we have parallel and perpendicular lines. Alternate interior angles, there are a lot of them. If we are talking about, here, hold on. I'm going to have you ignore some things to look at. So we're going to look at it like this first. So my alternate interior angles on this part are 3 and 6. And remember, you only need 6 sets. You don't need all of them. I don't think it would take all of them. And then 5 and 4. Those are alternate interior. Now, if we look at it this way, well, I meant to change colors, but oh well. Alternate interior 2, I should definitely make it littler. There we go. Are 2 and 11. Oh, I should do that in another color. And then 4 and 9. Right, and if I look at it this way, then we have 6 and 15. And then 8 and 13. And then last one is if I look at it this way, We have 11 and 14. And then 12 and 13. So there's a lot of answers for each of these. All right, then we have alternate exterior angles. So again, we're going to ignore parts of this to make it easier to see. I'm going to pick a different color instead of white so that I can actually use it. We'll do brown. Okay. Alternate exterior angles, 1 and 8. 2 and 7. 1 and 12. 3 and 10. Now let's look at it this way. And that would be 5 and 16. 7 and 14. 9 and 16. And then 10 and 15. Consecutive interior angles. That would be 3 and 5. 4 and 6. 2 and 9. 4 and 11. 6 and 13. 8 and 15. 11 and 13. And then 12 and 14. Consecutive exterior angles. 1 and 7. 2 and 8. 1 and 10. 3 and 12. 5 and 14. 7 and 16. 9 and 15. And then 10 and 16. All right, there are too many vertical angles for me to go over, so I'll do as many as I possibly can. This one I don't need to necessarily ignore, but we have 1 and 4, 3 and 2, 5 and 8. Maybe I can do all of them. 6 and 7. 9 and 12. 10 and 11. 13 and 16. And then 14 and 15. Now, linear pairs are one I definitely cannot show you all of them because all of the different possibilities. We can do 1 and 2. And I'll show you why on this one. 2 and 4. Because they just keep going around. 4 and 3. And then 1 and 3. So every intersection, there's 4 sets, which is why I'm not going to list them all. But you get the idea. They go all the way around. It's always 2 right next to each other. And then corresponding angles, that's the same side skip. So we have 1 and 5. 3 and 7. 2 and 6. 4 and 8. 'This one I won't have enough colors to do. 1 and 9. 2 and 10. 3 and 11. And then 4 and 12. All right. 5 and 13. 6 and 14. 7 and 15. 8 and 16. One last set of 4. Nine and 13. I'm only going to do 2 of them. I ran out of room. 11 and 15. And then it's also 10 and 14 and then 12 and 16. It's just not going to fit in the box anymore. All right. So now we need to know how they are related to each other so that we can solve problems with them. This uses 3 and 6, which are alternate interior angles, and they are congruent. So we set these equal to each other. Now, the easiest way to do this, a lot of y'all would distribute, but the easiest way is actually to divide by 10 on both sides to get this one out of there. And that turns this into a lot smaller numbers, which are a lot easier to deal with. So 2x minus 4 is equal to x plus 3. Subtract x on both sides. Add 4 to both sides. And x is 7. 4 and 9 are also alternate interior angles, just in another way. So 4 and 9 are equal. Subtract 4x on both sides. Add 5 to both sides, and x is 15. And then the other one is... there's 10, which is here. Oh, 10 and 9 are a linear pair. So we're going to use those together, but we already know what x is. So 9 is 4 times x plus 10, and that would be equal to my 10, which is 6y minus 4. And that's how we're going to solve this one. 4 times 15 is 60, plus 10 is 70. Add 4 to both sides. And then divide by 6. Wait. That's not right. 4 times 15. Oh, they're a linear pair. I am so dumb. I'm sorry. They are not equal. They're supplementary. Again, this is why I check my work. All right, 6y. 15 times 4 is 60, plus 10 is 70, minus 4, 70 minus 4 is 66. So plus 66 is equal to 180. Subtract 66 on both sides and you get 114. And then divide by 6 on both sides, you get 1. And sorry, the bell's ringing in 3 minutes. Oh, 5 minutes. I'm going to get as far as I can, and then I'll do 5 and 6 in another video. Use these points. What is the equation of a line that passes through that line up above? So passes through this line, and then passes through this. So, oh, that is parallel. Okay, so first we have to figure out the line for that. So our slope is, you subtract your y's on top. So 10 minus negative 6 is 10 plus 6. Negative 3 minus 5. That's 16 over negative 8, which is negative 2 is the slope. And that's all we really need because it's parallel to that line. We don't need the entire equation. Now we need an equation with a slope of negative 2 with that point. So y minus negative 8 is plus 8. And then negative 2x minus 1. Distribute that negative 2. And then subtract 8 from both sides, which would be minus 6. All right. And now it has to be perpendicular and through this point. Remember that our slope was negative 2, so our perpendicular slope is not negative, it is positive, and 2 is the same thing as 2 over 1, or negative 2 over 1. So when we flip it, it's 1/2. So our perpendicular slope is a positive 1/2. So y minus 9 is equal to 1/2 x minus 2. Distribute our 1/2. And then add 9 to both sides. All right, and then 4 and 5 will be in a different video. I'm sorry it's too long. I don't have enough time to make both.